Hey everyone, and welcome back to the channel. This is Medical Minis and we are continuing our course on understanding the basics of the ECG. So in today's video we will be focusing on the rhythm, the rate and the axis. In our previous video we had a look at the idea of sinus rhythms, so if you haven't watched that please make sure you do. So without further ado, let's get started. Alright, so let's talk about the rhythm. So when it comes to rhythm, there are two main rhythms you need to be aware of. Firstly, you have your regular rhythm, and then secondly, you have your irregular rhythm. Your irregular rhythms can be further subdivided into your regularly irregular rhythms and your irregularly irregular rhythms. Now, before we have a look into these different types of rhythms, how can we identify if one is regular or irregular? Well, it's quite simple. All you need to do is look at the rhythm strip or just generally look at the R to R intervals, and then you must ask yourself, are these intervals the same, okay, in terms of distance? So let's start off with this first example, and as you can see, when you calculate the distance between each R to R interval here, it's generally more or less the same distance, okay? It's around 6 or 6.5 boxes each, okay? And so because we have a similarity here between each of these R-to-R intervals, we can say that this is a regular rhythm. In our second example here, we can see that there is no longer this constant regularity. So what do we actually see? We see that there is some regularity, okay? However, this regularity is irregular. As we can see, there is a big gap between each of these R to R intervals here. So in this instance, we would say that this irregularity is regular or regularly irregular, okay? There is a regularity in the irregularity. And then finally we have this rhythm here, and as you can see there is no consistent rhythm here. It's all quite random. We have 2 R waves here, then 3, then a bit of a gap between these two, and so on and so on. Okay, so this one would be an irregular rhythm, okay? So now let's move on to the rate. The reason why I have put rate second after rhythm is because by knowing the rhythm, you can then choose how to calculate the rate, and I'll show you that in 1 minute. So when calculating the rate, there are two main types. So if you have a rhythm that is regular, the easiest way to calculate the rate is by using the 300 rule, which I will explain in a minute. Alternatively, if you have a rhythm that is irregular, you must use the rhythm strip rule, and I'll also explain that in a moment. So let's first look into the 300 rule. So here is an example of an ECG, and the 300 rule goes as follows. 300 divided by the large boxes between one R to R interval. But firstly, where does the number 300 come from? Well, this number is used because the ECG moves at a speed of 25 millimeters per second, and over a space of 1 minute, there would be 300 large boxes. 1 minute is important here because we calculate in terms of beats per minute. And so by doing 300 divided by the number of large boxes between one R to R interval, we can calculate the beats per minute. So how do we do this on the ECG? So let's try and find one R to R interval, and this is a good example here. You generally want to find R waves that overlap with a bold line. So here we can calculate the large boxes between, so we have 1, 2, 3, and 4 large boxes. So let's do 300 divided by 4 large boxes, and that should come to around 75 beats per minute. Now, if you had an irregular rhythm, you must use the rhythm strip rule. What is the rhythm strip? It is a 10-second long ECG tracing located usually on the bottom of the ECG. As you can see here in V1, V2, V5, we have this 10-second long ECG tracing. So what do you do in this rule? It's quite simple. All you do is calculate the number of R waves and then times it by 6. So you calculate the number of R waves and times it by 6. You times it by 6 because it's 10 seconds times by 6, which is 60 seconds. So you can then get your beats per minute. So let's do that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here we have 13 R waves, and then all we do is times it by 6. And what do we get? We get around 78 beats per minute. Okay, so as you can see, the options to calculate the rate, regardless if it's the 300 rule or the rhythm strip, generally you get the same answer. Okay, so this is important. If you have an irregular rhythm, you have to do this rhythm strip rule. However, if you have a regular rhythm, you can choose either or the 300 rule or the rhythm strip rule. It depends on what you prefer. Okay, so why is axis so important? Well, firstly, it allows us to identify, is there any pathology in the morphology or structure of the heart? For example, if the patient has, I don't know, a left-sided ventricular hypertrophy, okay? And secondly, it allows us to identify, is there a problem in the conducting system? Okay. For example, something like a bundle branch block. So how I like to calculate the axis is by using two leads, lead 1 and AVF. The reason being is, well, they are quite easy leads to think about. One goes in the right to left direction, and one just goes straight to the ground. Now, when you combine these two leads, what do you get? You get something like this, which is sort of similar to lead 2. Okay, and it's this particular area that's very important when it comes to axis. Like I mentioned in previous videos, lead 2 is a very important lead in itself because it follows this sort of physiological movement of the impulses within the heart. Okay, and this is represented on this image. Okay, and as you can see, the green area is our normal area. This is our normal axis. It goes from -30 to +90. Okay, and as you can see, it generally follows the same area that lead 2 follows. Okay, as you can see here, lead 1 is here. This is lead 1, 0 degrees, and here is AVF. Okay, and as you can see, this area pretty much takes up most of the proportion of the normal axis. Now, you could make the argument that using AVL and AVF would be the best because it outlines the sort of extremes of the axis, which is true, and that's fair enough. Personally, for me, I just like lead 1 and AVF because it's just very simple. Okay. Okay, so anything that comes outside of this range, outside of the normal axis, can be seen as pathological, but not always. For example, your right axis and left axis deviation can be physiological. For example, age. Okay, a right axis deviation is quite normal in a younger patient, and a left axis deviation is more common in an older patient. An extreme axis deviation, whilst very uncommon, this could be due to something like misplacement of your leads. So how do we go about calculating this? Well, there's a great rule everyone should use, and I advise everyone to use this all the time. It's the rule of thumbs. Okay. Okay, so how does the rule of thumbs go? Well, you locate your two leads you prefer. For me, I like lead 1 and AVF. And what you do is identify where is the deflection going. Your R wave or S wave, is it a positive or negative deflection? Based on that, that is your thumb. What do I mean? For example, on lead 1, where is the major deflection? Where is the main deflection? Well, it's negative, isn't it? There is this large S wave, it's the main deflection. What about an AVF? AVF, it's positive. The main deflection is positive. Okay, so that is what I mean by your deflection should be thought of as a thumb. Now, if your deflections in your leads, for mine, lead 1 and AVF, if you have two positive deflections or two thumbs up, if I give you two thumbs up, it means you're doing a good job. It means it's a normal axis. Okay, so if you have lead 1, that's a positive deflection, and AVF, that's a positive deflection. You have two thumbs up, and that's a good job. That's a normal axis. However, if you have, again, in lead 1, a positive deflection, however, in your AVF, if you have a negative deflection, a thumbs down, okay, what do you get? Well, you get a left axis deviation. So how I like to think about this is you have one thumbs up and one thumbs down. What are they doing? They are moving where? Away from each other. They have left each other. They have left each other. That's how I like to think about it. And the left means left axis deviation. Alternatively, if I have in lead 1, one thumbs down, a negative deflection, okay, and I have in my AVF a positive deflection, okay, what's happening now? Well, here I have a right axis deviation. Why? Well, my thumbs, what are they doing? My thumbs are moving what? They are moving right towards each other. They're moving right towards each other. And here you can say that this is a right axis deviation, right towards each other, right axis deviation. And lastly, which is the most rarest one, if you have in both leads two negative deflections, two thumbs down, if I give you two thumbs down, two negative deflections, you're doing a bad job, and that is an extreme axis deviation. Okay. Alright guys, that has been today's video. Today we've discussed the rhythm, the rate, and the axis. And in the next video we will continue our course on the ECG. If you guys enjoyed, please leave a like and subscribe, and I'll see you guys on the next video.